balance na layout. Station 1 includes A, B, and C. Station 2 includes E, D. Station 3 includes F. Station 4 includes G and H. Yes, hello everyone! So welcome to our continuation of the layout strategies na discussion. For this topic, we're going to have our line balancing and its application on how we can come up with a great layout. Okay, so layout strategies, line balancing. Let's start our discussion. So designing product layouts through line balancing. We have this set of terminologies that we may encounter during our study on the application of line balancing and on designing product layouts. First is what we call the line balancing. When we say line balancing, guys, this is the process of assigning tasks to workstations in such a way that workstations have approximately equal time requirement. As you can notice here, we have used the term approximately equal time requirement, not exactly equal time, dahil we can achieve it na eksakto talaga sila na line balance, no? Approximately equal lang. Somehow kasi may mga decimal points pa rin naman somehow. And next terminology that we may encounter is the term cycle time. Okay? Cycle time is the maximum time allowed at each workstation to complete its set of tasks on a unit. Maximum time allowed at each workstation. Okay, that is the cycle time. Next is the precedence diagram. A precedence diagram is a diagram that shows elemental tasks and their precedence requirements. When we say precedence diagram, this is basically a diagram just like your project management, the deferred CPM, the network models under your operations research. So that is a diagram. No, that is a flow. Pinapakita niya yung flow, yung connections niya. So dito mga task naman. No, precedence diagram ang tawag diyan. Now, how a line is balanced. Actually, we have this idea that there's no such thing as the best technique available that guarantee an optimal set of assignments. There's no such thing like that. Instead, managers, engineers, and owners or the bosses of the companies employ heuristics. When we say heuristics, guys, this is an intuitive approach, no intuitive rules in which provides good and sometimes optimal sets of assignment. Pero pag sinabi natin na eksakto, optimal yan, optimum yung ganyang line balancing natin in relation to our layout, wala pong ganun. No, more on heuristics yung topic na ito, more on intuitive. Okay? So, we have here the two line balancing heuristics. The first one is that we should assign tasks in order of the most following task. That is the first heuristics natin. For the second heuristics, we should assign tasks in order of greatest positional weight. And what is a positional weight? Basically, a positional weight is the sum of each task time and the times of all the following tasks. That is what we call the positional weight. Okay, so for you to be able to understand this topic more, let's have an example here. So, for the example, arrange the tasks shown below into 3 workstations. So, we should come up with 3 workstations. Use a cycle time of 1 minute. Okay? Again, by definition, cycle time is the maximum time allowed at each workstation to complete its set of tasks on a unit. So, 1 minute. Assign tasks in order of the most number of follower. Okay? Most number of follower, this is the first line balancing heuristics. Okay? Let's have it here. 1. Para maalala natin na first, heuristics yung gamit natin. Okay? So, this is the precedence diagram. Ito po yung sinasabi kanina. This is their connection. So, the task A is actually 0.1 minute, task B 1 minute, task C is 0.7 minutes, D is 0.5 minutes, E is 0.2 minutes. So, what we should do is, ano yung tamang combination ng mga task na yan? Ano-ano yung mga task na papagsamahin natin into a single workstation for a total of 3 workstations sa buong process na yan. Okay? Sa buong precedence diagram. So, what we're going to do is to divide this whole precedence diagram into 3 workstations. Okay? So, let's start our solution. Now, let's have our first workstation first. Okay? Our first workstation. For the time remaining, di ba sabi we should always have a 1 minute cycle time per workstation. Okay? So, meaning we have here 1 minute. Okay? And our eligible, since our heuristics says that we should assign tasks in order of the most number of followers, therefore, we should start with our letter A. Dahil siya yung isa sa pinakamaraming followers. Why? Si letter A is B, sumusunod sa kanya si B, si D, and E. Ilan po yun? 3. While si C is sumusunod sa kanya si D and E, 2 lang. Therefore, dun talaga tayo mag-start with letter A. Siya kasi yung task with the most number of followers. Okay? And, ang eligible dyan is only letter A. Therefore, we can assign this task to letter A. Okay, revised time remaining, since the letter A is 0.1 minute, we can have here a 0.9 minutes na natitira. Okay, station idle time, wala pang idle time dahil we are just maximizing the station, the workstation. Okay, now we have now 0.9 minutes na time remaining and the eligibles now are, kung titignan ninyo, pwede natin idugtong si B and si C. Bakit? Dahil si B, may kadugtong siyang 2. Okay, si C may kadugtong din siyang 2. Okay, so we can choose between B and C. But we will choose to assign it to task C. Why? Kasi po, kung titingnan ninyo, natitira na lang natin is 0.9. Okay, si B is 1 minute, so hindi na siya kasya. Hindi natin pwedeng isiksik si B sa workstation 1 dahil ang cycle time niya is 1 minute. Dahil si C is 0.7, kaya po siya yung pipiliin natin. 0.7, meaning 0.9 minus 0.7, we still have 0.2 minutes. And wala pa tayong idle time. Okay, wala pa. Minamaximize pa lang natin. So, we still have here 0.2 minutes. And eligible natin for now is si letter B is not eligible dahil di siya pasok 1 minute na yan And si D is 0.5, hindi na rin. So, we don't have any eligible ngayon, no? Wala na. Assign task, wala na rin ito. Revised time remaining, wala na po ito. Therefore, this time remaining na 0.2, that will be the idle time for this workstation 1. Okay, so meron na po tayong first workstation and ang magkasama is si workstation A and C. So, actually, pwede tayong, pwede natin silang lagyan na ng barriers. So, pwede, ito na. Ito ang first workstation natin. Yan, sila ang magkasama. Workstation A and C. Okay, workstation 1. Okay, so next natin is for the workstation 2. Okay, for the workstation 2, guys, A and C, hindi na pwede dahil nandun na sila. Most following. That is basically the letter B. May 2 kasunod. Kapag pinili natin si D, isa lang kasunod niya. So, let's start with the B. Okay, so time remaining, 1 minute per cycle daw po, per workstation. And eligible is the letter B. Assign task to letter B, of course. Revised time. Letter B is actually eksaktong 1 minute siya. Okay, so revised time remaining is 0. Therefore, we don't have any idle time for the letter B. And si letter B na mismo ang ating workstation number 2. Wala na siyang ibang kasama dahil na-maximize niya na yung available natin na 1 minute cycle time. Okay? So, this is it. Letter B. This is our workstation 2. Okay? So, let's continue our solution for the workstation 3 na tayo, no? So, workstation 3, we have it here. 1 minute left. Okay? And our eligible are the most, the task with the most number of followers, which is D. No? Nakasunod sa kanya si E. Hindi na pwede si E. Wala na siyang kasunod So, our eligible now is the letter D. Okay? And we should assign it to letter D. Based on the precedence diagram, letter D is 0.5 minutes. Okay, so 1 minus 0.5, that is 0.5. Okay, wala pa tayong idle, then we're not yet finished. Then hindi pa natin na-maximize. So, our time remaining here is 0.5. And the eligible na lang is the letter E, right? So, letter E here, eligible, and we should assign it to letter E also. And since based on the precedence diagram, letter E has 0.2 minutes na working time. So, 0.5 minus 0.2 is 0.3. Okay, and we are not yet idle. So, we still have 0.3. And kung titingnan ninyo, wala na po siyang kadugtong with the precedence diagram. Therefore, wala na tayong eligible. We don't have an assigned task here. The revised time remaining is ganun pa rin. Hindi na siya na-revise. Therefore, that 0.3 is now the idle time. So, ibig pong sabihin, this letter D and letter B will be our third workstation. Okay, they will be the workstation 3. And in that point, guys, we are now having the final line balance layout, just like what we have before. Okay, so workstation 1 for the task A and C, workstation 2 for the task B, workstation 3 for the task D and E. Now, the question is how we should assure that we have the effective line balanced layout. Okay, measures of effectiveness. So for the measures of effectiveness, we have actually two. For the first one, that is the percentage of idle time. Second one is the efficiency. When we say percentage of idle time, this is also known as balance delay. Okay, for the formula niya, that is equivalent to the percent of idle time equals idle time per cycle. Okay, over the N actual. This N sub-actual is the actual number of workstations that we have multiplied to the cycle time times 100. So, let's compute for the percent of idle time. Let me change first the color of my pen to white. Okay, so let's have it here. Okay, percent of idle time. Okay, so percent of idle time equals idle time per cycle. Now, what is our idle time per cycle? As you can see, we have 0.2 and 0.3. So, total is we have 0.5. So, this is our idle time for the whole cycle. So, 0.5 over N sub-actual, number of workstations. We have 3 workstations, right? So, we need to have 3 here. Times the cycle time, which is 1. Okay? Times 100. And basically, the 0.5 over 3 times 100, this is 16.7%. So, meaning, no, we are actually having 16.7% idle using this balanced layout. Somehow, medyo malaki, pero ito na yung optimum. Okay, so that is the first na measures of effectiveness. For the second measures of effectiveness, we have the efficiency of the line. So basically, efficiency of the line is 100%. Okay, 100% minus the percent idle time. And basically, ganun lang siya, i-minus mo lang. Yung na-complete natin dito na 16.7 na minus natin sa 100%. And that is equivalent to 83.3%. Meaning, this layout is 83.3% efficient. Okay, so that is for our first example. Let's move on now to our second example of line balancing applied to layouting. For the second example, using the information contained in the table shown, do each of the following. So first is draw a precedence diagram. Okay, assuming an 8-hour workday, compute the cycle time needed to obtain an output of 400 units per day. Kailangan maka 400 units tayo. No, and determine the minimum number of workstations required. Ito, wala siya sinabi, no? We should determine. Unlike sa first example na sabi niya, gawin natin 3. Okay, tatlo. And sinabi niya na yung parang sagot na yun, nagiging tatlo. Ito, hindi. No, we don't have any clue gaano karaming workstation ang magagawa natin. Basta ang goal natin, we should produce 400 units per day. Okay, and next, 4 is assign task to workstations using this rule. So, our heuristics na gagamitin is to assign task according to the greatest number of following tasks. And this is the number 1 heuristics, the first heuristics. Okay, in case of a tie, use the tiebreaker of assigning the task with the longest processing time first. So, longest processing time. Next, number 5, compute the resulting percent idle time and efficiency of the system. Yung last na ginawa natin sa first example. So, here's the given and we should have the precedence diagram first. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 tasks here. So, sige, let's start, no? Let's start having our precedence diagram. Okay, so let's have it here. This is letter A. A is 0.2. Okay, so 0.2. Kasunod sa kanya is si letter B. The predecessor of letter B is letter A. Okay, so let's have here letter B. And that is worth 0.2 minutes then, task time. Okay, so 0.2. And as you can see here, okay na to. Okay na to. Letter C. Si letter C, it doesn't have any predecessor, pero nakadugtong sa kanya si D. Okay, so meaning guys, somehow nagiging parallel si C and D kay A and B. Therefore, pwede nating pagtapatin si A and si C. Okay, so let's have letter C here. And C is 0.8. Okay, so 0.8. Nakadugtong sa kanya si letter D. Okay, which is 0.6. So, letter D here. I'm sorry. Sa loob ko pa isusulat yung number. Pero may gano'n, no? May gano'n. It is up to you. There is no such thing as standard format naman dito. So, letter D. Okay, and 0.6. Okay, now, what is the next one? Letter E. Ito po, letter E, predecessor is letter B, which is 0.3, task time. So, letter E, predecessor niya B, dito siya. Okay, with task time of 0.3. And next natin, we have F, which has two predecessors, D and E. So, D and E, this one and this one. So, pwedeng dito natin ilagay si F or sa gitna, pwede rin naman. So, pag ganito siya. Okay, and ito pa ganyan. We have here 1 task time. Okay, 1 minute task time. Next. Letter G, predecessor is F, 0.4. So, let's have it here. G, 0.4. Okay, and next we have H. Predecessor niya is si G with 0.3 task time. So, H, 0.3. Okay, so here's now our precedence diagram. Now, for the cycle time is operating time. Okay, let's have here the formula. Operating time. We should determine daw the cycle time. Walang binigay, no? Operating time over the desired output rate. Okay, desired output rate. So, let's start here sa given. Sabi sa given, we have here 8-hour work day and 400 units per day. Since our given here is in 2 minutes, tapos dito naka-oras, siguro ito na lang i-adjust natin. Okay, let's multiply this to 60 minutes per hour and that we will have Actually, 480 minutes per day. Tama? Okay, so, ayun ang magiging operating time natin. We have here 480 minutes per day. Okay, over our desired output rate, which is 400 units per day. Okay, so 400 units per day. Okay, so 480 divided by 400. Let's have it here. 480 divided by 400. That is 1.2. So our cycle time is 1.2 minutes or 1.2 minutes per cycle. So ayun po yung tawag natin dyan. Now, for the third one, so okay na tayo with this one. Determine the minimum number of workstations required. Gaano kaya karami ang workstation na kailanganin natin. Okay, so for the total number of workstation, that is summation of our time, which is, kung titignan nyo dito, 3.8 ang total task times natin. Okay, so 3.8 minutes over summation of task time over the cycle time. You know, the CPU, which is 1.2 minutes per cycle. So 3.8 minutes divided by the 1.2 minutes. Okay, so 3.8, let's have here 3.8 divided by the 1.2, that is 3.17. Okay, so 3.17 workstations. And guys, sir, wala naman 0.17 na workstation. Ano yun? Merong hati, may tapyas. No, always round up po tayo. Therefore, we'll be having a total of 4 workstations sa ating line balancing. Wala pa po tayo sa mismong computation ng line balancing. We're just having the prerequisite, kumbaga, sa computation. No, so, we're done with this third na need natin gawin. So, let's start now the assigning of the task per workstation using the first heuristics that we have. Okay, so let's start po. So, station 1. Okay, time remaining, sabi natin doon, we have 1.2. Tama? Ito po siya. 1.2 cycle time per workstation. Yung kanina, sa first example natin, we have there a 1 minute per workstation na cycle time. Dito, 1.2. So, our time remaining is 1.2. And the eligible, kung titingnan ninyo, sabi kasi sa heuristics natin, assign task according to the greatest number of following tasks. And based on the precedence diagram, it is A and C. Dahil nakadugtong kay A is 1, 2, 3, 4, 5. And nakadugtong kay C is 1, 2, 3, 4. Okay, so, ang pinakamarami actually is si A. Pero, kung titingnan po natin, no, sa eligibility, pasok din si C dahil 0.8 din siya. No, mas maliit siya sa 1.2 na remaining time natin. So, A and C lagay natin dito. But the only fit for now is pareho din sila. No, hindi only Actually, pareho sila fit. So, A and C. Pwede natin yung ilagay. No? Pero ang pag-assign natin, isa-isa lang muna. Unahin natin si A. Okay, si A, which has, gaano katagal? 0.2. Okay, 0.2. So, 1.2 minus 0.2, that is 1 minute. We don't have any idle yet. Okay, so mayroon tayong 1 minute na natira and eligible pa rin si C. Tama? Pero for now, if you'll check, dahil okay na si A, eligible na rin dyan si B. Tama? Okay, so si B and C or si C and B, pwede natin ilagay dito. But we can actually fit here si C. Si B is 0.2, si C is 0.8. Unahin natin si C. Okay, pareho sila mag-fit, no? Pero unahin natin si C, which is 0.8. So 1 minus 0.8, that is 0.2. We don't have any idle yet dahil di pa po tayo tapos. Okay, so 0.2 time remaining, eligible si B. And dahil okay na si C, eligible din si D. Okay? But it will only fit letter D dahil si D is medyo matagal 0.6. Okay, so si D dito. And that is 0.2 si B. So 0.2 minus 0.2, that is time remaining natin na 0. So we don't have idle time. Time remaining 0. No, eligible na tayo na this time is si E and si D dahil din ay mga kadugtong nila. Pero wala nang mag-fit dahil nga po 0 na tayo. So 0, wala na to, and we don't have idle time. Therefore, yung laman or yung mga tasks under workstation 1 are the task A, C, and B. Task A, C, B. Okay, so they are actually part of our first workstation, ACB. ACB, pwede pa ganyan. So, ang workstation 1. Bahala kayo kung paano nyo hahatiin. Pero, ayun, basta sila yung nasa loob. Ayun. Okay, so workstation 1. Okay, so next, let's start with workstation 2 na. Time remaining 1.2 dahil again, we have cycle time na 1.2 per workstation and the eligible is the E and D. Dudugtungan lang natin yung ating natapos last time. So, will fit pareho po sila. No, dahil si E is actually 0.3, si D is 0.6. Ang ating max is 1.2, so pwede sila. Pero unahin natin si D muna. No? Or si E, depende sa'yo kung ano. Wala naman rule dito. Dahil ulitin ko nga, this is more on heuristics. Intuitive. Okay, so 0.6 si D. So 1.2 minus 0.6, we still have 0.6 time remaining. No idle for now dahil di pa tayo tapos. So 0.6 time remaining here. And eligible is si E. Okay. And eligible na ba yung next natin? Si F. Actually, hindi dahil 1. No, 1 minute siya. So, ang ating mag-fit is si E, which is si letter E, 0.3. So, 0.3 letter E. 0.6 minus 0.3, that is 0.3. We don't have any idle dahil di pa tayo tapos. So, 0.3 tayo dito. Eligible, pwede si F. Actually, pwede si F, pero 1 minute siya. Eligible siya, pero hindi natin siya i-assign. Hindi siya mag-fit. No? So, inanan natin yan. Actually, dito pwede mo na rin ilagay si F. No? Kung gusto mo, sige, lagay natin si F. Pero wala, tulad nga po nung nasabi ko, no, wala pong exact rule dyan na dapat dito isa o dalawa lang. Dahil heuristics ito. Ang importante, we must come up with the same na workstations. Yung mga tasks doon sa workstation na pare-pareho tayo. Okay, so F, none. Wala to, and we have an idle time of 0.3. Therefore, under the workstation 2, we have D and E. Okay, so D and E. Ito ang mga workstation 2. Okay, so ito ang ating workstation 2. D and E. Ito na ilagay. W2. Okay, so next, workstation 3, we have 1.2 time remaining. Eligible natin for now is letter F. Okay? Letter F is 1, si G is 0.4. Hindi pa po siya eligible dahil may nakaharang pa, which is si F. Okay, so F unahin natin. So F here, so we'll fit F. F is 1 minute, tama? Okay? So 1.2 minus 1, we have 0.2. Wala pa tayong idle dahil we're not yet finished. So 0.2 time remaining. Eligible na ngayon si G. Pero it will not fit dahil 0.4 po siya. Okay? So wala tayong assigned task. Wala tayong assigned task. Ito, none. No, walang mag-fit eh. And we have an idle time of 0.2. Therefore, under the third station, mag-isa lang si letter F. Okay, ito na yung ating workstation 3. Okay, this is the workstation 3, letter F. Next, let's start our workstation 4, 1.2 time remaining. We have G. Hindi pa natin makakonsider na eligible si H dahil may nakaharang pa na G. Okay, so we have here G, and it will also fit dahil G is 0.4 minutes. So 1.2 minus 0.4, that is 0.8, and we don't have any idle yet dahil we're not yet finished. So 0.8 time remaining, eligible na po si H. And if, as you can see here, 0.3. No, pasok siya, it will fit. So H dyan, H 0.3. 0.8 minus 0.3, that is 0.5. We don't have any idle yet. Meron pa tayong time remaining na 0.5. Pero wala na po tayong kadugtong na task based on our precedence diagram. So meaning, wala na po ito, wala na to, wala na to, wala na to, and we have an idle time of 0.5 on the last workstation. Last workstation includes as a task G and task H. Okay, so ito ang ating workstation number 4. Magkasama sila. Okay, workstation number 4. So, next, guys, actually, this is the final na itsura ng ating line balance na layout. Station 1 includes A, B, and C. Station 2 includes E, D. Station 3 includes F, station 4 includes G and H. So, itong layout na yan is actually line balance na sila. Pag naglabas sila ng output, balance na at the same time, may hit nila yung ating target na 400 units per day. Okay, so, ayan po siya. Next natin, actually, okay na tayo dito, number 4, no? Next is we should now compute the percent idle time and efficiency of the system. So, let's go for it now. Percent idle time. Okay, this is the idle time per cycle. Diba? Kinaalala ninyo? Idle time per cycle. And as you can still remember, our idle time per cycle is compute nga natin. Na-compute na ba natin? Di pa yata. So, ito, total. 0.3 plus 0.2 plus 0.5, that is 1 minute. Okay, so we have here 1 over the n sub actual, or the number of workstations multiplied to our cycle time. We have 4 workstations, so over 4 times our cycle time is 1.2, right? Ito, no, 1.2 tayo nagsisimula eh. And this is actually has a basis naman, ito po siya. So, 1.2. So, 4 times 1.2 equals, let's have a computation here. Divide 4 times 1.2. We have 0.2083. Okay, so 0.2083, or this is equivalent to 20.83%. Meaning, no, 20.83% of the time is actually idle. And for the efficiency, that is 100% minus 20.83%. Okay, so minus natin. 100 minus 20.83, that is 79.70. So, meaning to say, guys, 79.17% efficient itong ginawa natin na layout. Okay, based on line balancing technique. And I hope, guys, you learned something in this discussion, no, that ends up our discussion regarding the application of line balancing in layout strategies. Okay, so thank you for being with me on this topic. See you on our last topic under the layout strategies, which is all about the designing of process layouts naman. Okay, so again, thank you, keep safe, and see you on our next topic.